Hello, Keith Rucker here at VintageMachinery.org. Guys, today it's a new machine day. I'm pretty excited about this. I don't know, it's probably been a month or two ago, I was contacted by a viewer up outside of Baltimore up in Maryland who told me that they had this machine in the shop he was working at. They were looking to get rid of it, and that if didn't find someone for it soon, it was probably going to the scrapyard, and I just couldn't let that happen. Yeah, so I adopted another machine for the shop and I brought it in here. So actually he contacted me like within a week or so of when he contacted me. I was going to Baltimore with my in-laws and my wife for a little family trip that my in-laws wanted us to go on with them. So while I was on that trip, I rented a car. I drove about 45 minutes north of Baltimore. I went and checked the machine out in person, got to inspect it, actually there at the shop that it was in, visit with the guys that had it, and purchased it right there on the spot. I then had to work on getting it moved here to my shop, and for that I contacted Fred Newman, who I've used in the past, who does some hot shot delivery work, and he worked it out where he was able to swing by, pick it up, put it on a trailer, and bring it down here to me. And this came in just in the last couple of days. We got it unloaded and in the shop. And today, what I want to do is introduce you guys to this machine. I want to get it cleaned up a little bit and just start kind of playing with it a little bit because I've never used one. I'll be honest with you, I've never used one of these. I've got the manual. There's going to be some trial and error in figuring out how to use it, and I know that the way they had this one set up, they weren't cutting gears with it. I'll talk about that in a little bit. They were actually doing kind of a knurling operation with it, but it's designed for cutting gears. What is a gear shaper? A gear shaper is a high-speed gear shaper. It's made by Fellows. It's a 7 type is what it goes by, type 7, and basically it is used for gear cutting. And instead of using an involute cutter on a horizontal mill like we do in a dividing head to actually do it, they've got a round disc that has basically a gear in it. It's a cutter, but it looks like a gear. It's going to have so many teeth in it for a particular pitch, and it mounts on this arbor up here. Your gear blank mounts on this shaft here, I think, and we'll get the specs out in a minute because I'm going off of memory and I may not have this exactly right. I think that you can do up to about a 7-inch diameter gear on this one here, and that you can do up to a 6 diametral pitch, which is pretty good coarse size gear. Of course, the finer gears are not a problem, but you can go up to I think it's a 6 pitch if I remember right. We'll double check those in a little bit. But basically you mount that cutter on here. This cutter, like a metal shaper, it has a stroking action. In this case, it's going to be moving up and down and through some change gears. And this came with a whole pallet of gears that go in this thing. So I'm hoping I have a complete set of change gears. I got to figure out what I got. But you basically adjust the ratio of the number of teeth on the cutter that you're using and on the blank that you're cutting, and they turn where basically it's just turning both gears simultaneously at the same time, stroking as it goes, and it's just shaping out that profile, and it's just meshed all the way around. So you don't really have a dividing head in this case. You're not cutting each individual tooth, and each individual tooth is getting a lot of different strokes that goes through that circle. The nice thing about these gear shapers is that it will make if you've got a good cutter that has the right profile on the gear tooth itself, as it does this, you will cut a perfect involute for that particular pitch size and that gear size. With a involute cutter on the horizontal milling machine, there's like 8 different cutters that you can have, and each one of them is for a range of number of teeth on that gear, and basically the shape of the involute on those gears is going to be approximate. It's not going to be exact. With this machine, you get an exact profile, so you actually get a smoother running gear. This particular machine will only do spur gears, so straight across gears. They made these machines that could do helical gears, bevel gears, all kinds of things like that. This one here is pretty much just straight up and down. Like I said, it does not. They had a version of this same one that you could set it up as the cutter was going down, it would twist and that was for doing helical gears, and basically the other piece twist with it, so it was cutting that helical gear with a nice perfect profile on it. This one here is strictly for spur gears, so, which is mostly what I cut. So I do a fair amount of gear cutting, usually over on the horizontal milling machine with a dividing head. It works just fine. I've always read about these gear shapers and how well they work and everything else. I've always said, you know, I'd like to play around with one of these. So, you know, is this a long-term machine that I'm going to keep in the shop? I don't know. You know, it's fairly small footprint, about 4 foot by 4 foot. You know, so it's not like it's taking up a huge amount of space in the shop, but it is taking up space just for gear cutting. So, you know, I may end up at some point in time letting this one go. But I do want to play with it for a while and kind of learn how to use it. So right now, I think what I want to do before I do anything else is kind of get this machine cleaned up. It came into the shop pretty much as it left the shop up there. They told me that they were using this machine that was set up to do a job. And that's one thing about these. These are really more for production work than they are cutting individual gears. You can use them to cut an individual gear, but they were typically more for production work. Where you were just making a constant part over and over and over again. In the case of this one, they were making knobs for microscopes. They actually had a contract with Bosch & Lomb, who is, of course, an optic manufacturer. They make, you know, I think most people are probably familiar with eyeglasses, but me being a scientist in my professional life, I'm very familiar with Bosch & Lomb optics from a microscope standpoint. But the little adjusting knobs on them, they were cutting the little knurls, the serrations on the side, and that's actually the cutter that's in here right now is set up for doing those knobs. And I think over here, I went through some boxes there. I think there were actually a couple of knobs that were in there that we can kind of show you here a little bit when we get to that point. So right now, let's see about getting this thing cleaned up. Now, one thing I will note is that this machine was not really using coolant, but you actually had a sump down here that was full of cutting oil, and it basically just dribbled cutting oil right here on the part. This little hose would come over here, and it was just flooding cutting oil. So the whole time that thing is going up and down and turning at a fairly high speed, it's just dousing it with cutting oil. Now, they drained most of the cutting oil out. I got a couple of 5-gallon buckets over here that they took the cutting oil that was in here. There's still some down in the bottom of the sump. I really want to get that cleaned out. There's a lot of just metal shavings on this. I'm probably going to try to get the rest of the oil out of this. We're going to take it outside, and I'm probably just going to get the pressure washer out and with some degreaser and try to get this thing cleaned up. And then we'll bring it back in the shop and start trying to maybe play with it. I did see it under power. It wasn't actually cutting. They didn't have a blank to put in to actually cut with, but I could see that it was working before it came down here, so hopefully it's still working, should be. All right, let's see about getting this thing cleaned up. So before this left, they drained out as much of the oil as they could. I went in here and put a couple of pads in here to kind of absorb some of this oil and hopefully kind of get it out. So let me get these in here. There's still a fair amount in there. I'm gonna probably get some more of those pads and put them in there and just let them soak that up. And the bottom of this thing is full of gunk too. So I really want to get all that cleaned out. Let me get some more of those pads and we'll put them in there and let it soak some more up. And we'll take some more of these pads and we'll just let them sit in here for a few minutes and soak. These are I call these pig mats, and they're for absorbing oil. They do a really good job of that. And I'm just kind of using them to help get this thing cleaned out. While that pig mat is soaking, I'm just going to take a putty knife here and start trying to scrape up all this crud in here and try to get as much of this out of here as well. Yeah, it's got about 50 years of crud on here, it looks like. So guys, it is the next day. I'm back out here in the shop. I will note that I've got some help in the shop today and got some machines running, so apologize for any background noise you may hear, no big deal. I don't think it's going to be that big of a deal on the video, but just letting you know what's going on. So yesterday, got the machine outside, got it cleaned up, basically, well, first thing I did was went around and got as much out of it as I could, scraping out all the oil out of the pan down here and getting all the chips out. That got filthy nasty. And then got out my pressure washer and some degreaser, squirted this thing down and cleaned it up. And it is in much, much better looking shape now. At least it's not grimy to the touch, so I feel a little bit better about that. But anyway, at this point, just kind of continuing on, like I had mentioned before, this is a new machine to me in the purest sense in that I've never used one. I've seen some being used. I'm familiar with them at a very high level, but I don't know all the details. I got a lot to figure out in this machine, and we're going to be trying to look at some of that as we go. I think the first thing I want to do, though, is get it plugged up, fired up, and let you guys kind of get an idea of how this thing works, and then we'll talk a little bit more about the details. And I've already seen a few little things I need to kind of check out and figure out what's going on. So let's fire it up and show you what's happening. So before we do fire it up, let me just kind of show you a close-up here of what's going on. This is basically where all the action happens. Now, remember I told you that this machine was not set up for cutting gears when I got it. It was set up for cutting knurls and knobs to go on microscopes. And the cutter that is in here is kind of a knurling tool rather than a gear cutting tool. But from the standpoint of this machine, it works exactly the same. You got so many teeth or so many notches or whatever on the cutter. You got so many over here. You figure up the ratio between the two, and you basically are just shaping these things out as they go. And they had a little custom thing here to hold your work in. This is a little bit different again from what you normally do with gear setups, but they had a little fixture that held the knobs in place. And this part is going to just go up and down. It's going to rotate. The part over here is going to rotate simultaneously and cut that out. Now, this is kind of what the cutters look like. This is also a knurling cutter for a much coarser knurl, obviously, but you can kind of see what it is. You got your teeth on here. This is a sharpen on the bottom, and this tool is just coming up and down and rotating at the same time, timed with the work so that you get your part. Now, I will note that the cutters that are in here are smaller than the gear cutters that's really designed to go on this machine, and I suspect they may have changed this tool holder out at some time because the gear cutters, according to the manual, are supposed to be about 3 inches in diameter, and that's, I don't know, maybe 1.5 inches in diameter. So these are much smaller, but obviously, you know, it's flexible. You can do whatever. I believe you can remove this arbor. We're going to take a look at that in a little bit, and you may have to see about getting the correct arbor to hold the right kind of cutter for cutting gears, but shouldn't be a big deal. All right, let's fire it up and show you what's going on. All right, let's hit the power switch, and you'll start seeing this go up and down and turning, I suspect. Let's see what happens. There we go. So you can see the part is turning. And I don't know whether you can see it or not, but the actual, this should be turning as well. I'm watching that flat. Yeah, it is rotating around. And these two are timed again through some change gears so that based on the number of teeth on your cutter versus the number of teeth on your item that you are cutting, they're turning in the proper ratio with one another. And of course you can adjust the stroke length, you can adjust how far in and out it goes, you can adjust the feed rate, you can adjust the speed, all that kind of stuff is adjustable for this machine. So I'm going to turn it off. You can also see that this thing is kind of, when it's on the upstroke, it kind of moves out. So you got a little relief. On the downstroke, it moves back in so that your tool's not dragging coming back across there. So I'm looking over here on the side of the machine, and this is where the change gears are that you basically have to adjust for the number of teeth on the gear you're cutting. And basically you got in here the number of teeth in the cutter, the number of teeth in the work, And depending on these numbers, there's some numbers in here. There's a mathematical formula that you use, and basically that'll tell you which change gears you need to use for A, B, C, and D. So yeah, a little bit of math involved there. It's all spelled out for you. I actually put together a spreadsheet that will do the math for me, so that I had the manual a couple of weeks ago and I was bored one night, so I just wrote a little Excel spreadsheet where you put in the number of teeth in the cutter, the number of teeth in the work, and it'll calculate which change gears you want. And these are the change gears that you put in here. And I've got a whole box of change gears over there that go to this machine. Hopefully I got a full set. I'm not going to open this up right now, but if you take these screws out right here, there's another set of change gears on this side, and this determines your feed rate, so how much of a cut is taking on each pass. And there's some instructions in here to kind of figure out which ones you need to use, and that's again the manual. I haven't done all the math on this one yet, but I think I can do that. I just got to sit down and do it. And like I said, I'm not going to open that up at the change gears. It's a different style of change gears that goes in this side, but I do also have the change gears, a whole set of change gears for those as well. I've been taking some inventory here of the stuff that came with this. There was basically a box with just a bunch of parts in it on a pallet, and I'm kind of been sorting them out. So first off, back here we have change gears. These thicker ones here are for the ratios that we were talking about earlier, where you can change gears out to get your ratios right. And then the smaller, thinner ones here are for your feed rate. And again, you can change these out to adjust those settings. I do not have a list of what change gears are supposed to be with the machine. So I don't know if this is a complete set, partial set, missing some, but the good news is I've got a pretty good selection of change gears here, so hopefully we'll have everything we need when the time comes to start doing some things. Bunch of cutters down here. Again, knurling cutters is all that I have with this currently. I do not have any gear cutters. I did order a gear cutter. I found one on eBay, used one, just to play around with. I'm not sure if you can get these or not. And like I mentioned before, these knurling cutters are smaller than the gear cutters that we'll be actually using. And I did look in the manual, and you can change the spindles out that mount these cutters on. And in fact, we have a couple of spindles that were in there. And I believe that this spindle here is the one for these smaller cutters. So they fit up. Actually, no, this one fits a different size cutter. But they fit up on there, and basically there's a shoulder bolt that goes up in there. Same thing here. This is the one that will fit the cutters that I've got, which have a 1.25 inch inside diameter, and they're roughly 3 inches in outside diameter. The actual diameter changes a little bit depending on the pitch of the gear, but that's the spindle that needs to go in there, and I'm gonna probably try to change that out here in just a little bit. There were some extra collet fixtures here for holding work holding fixtures. There were these blocks. I'm not sure. I think that these might be for mounting work on as well. I need to figure some of that out. Here are some of the knobs that they were knurling. Looks like some samples of them here, and some tools and stuff to go along with it. There's even some spare parts. Here's a little that's the rocker arm that goes in there. But anyway, there were some spare parts in the box that they had ordered, and looks like never even put in on the machine. So we do have a few spare parts. So anyway, that was kind of what came with it. Just a close-up on the cutters here. Again, this is a knurling cutter, and these are smaller than the ones that we'll probably be using. You can sharpen them. Basically, you sharpen them by grinding the bottom of these, but it's at a little bit of a angle. It's not just flat across. It's kind of dished out. And in one of my manuals that I was looking at, it actually gives the instructions on how to set up a tool and cutter grinder to grind to sharpen these. So that'll be handy as well, I'm sure. So anyway, a bunch of different cutters that we'll probably never use, but I'm on the lookout for some of the correct gear cutters because that's what I'm mainly interested in. All right, I'm over here at the shaper now, and I want to try to change the spindle out. So this looks like a fixture that they had for holding some of these parts that they were cutting. It was just a little homemade fixture, and that's mounted on a collet chuck, I believe. Let me see if I can get that loose. There we go. So that should loosen that collet up. And I'm going to have to back off my cutter here to get that out, but that's just a collet block that holds a fixture for mounting that worker too. Let me see what we got to do to move this thing back. So I'm going to go ahead here now and move this cam back here on the back, which should allow this to kind of relieve back. There we go. This basically controls the depth of feed according to this cam. And then when it gets all the way around here, boom, it relieves back. So this is when you're starting a new cut. It'll kind of gradually feed in to the depth you want, and then it stays at that depth for the rest of the revolution, and then at the end it'll automatically relieve back out when your gear's cut. So now I've got room to pull this little fixture out of the collet, and I think I'm going to go ahead and remove this collet block from here. Now, according to the book, there's a tapered arbor that fits down in here that your gears fit on. They have put these collet blocks in here that they're actually been mounting these microscopic knobs on, which is a little bit different, but I think it's just what you got set up in here. So we're going to take a look at that real quick. So I'm just going to unscrew the collet tightener here. There's our collet, and it looks like there's 3 nuts holding this on, although they're looks like the nuts are just barely got room. In fact, one of them's not even attached at all. Let's get a wrench and get those out of there. Just loosen that up. All right, that comes out. Looks like that just screws up from the bottom maybe. Oh, it's just a stud that goes down in there. And that one was shorter than the other one. That's the reason. Maybe it's broken. I bet that's what happened, was it broke. Yeah. I'm going to get this cutter off of here. It's just mounted up underneath the bottom here with a socket cap screw, I believe is what it is. And let's see, we want to loosen that up. I think that got it loose. Yeah. Got a cap screw and a washer, and that just comes right off. Now what I think I want to do is take this plate off. I'm a little confused about this. My books and everything talks about there being a tapered shaft that comes up through here that you mount your gear on, whereas this has just had this collet chuck put into this little plate that's been added in here. I'm not sure if this is the correct plate for the way I want to use the machine or what the deal is. I think I'm just going to go ahead and take these off and pull it off and figure out what we're dealing with here. So let me get something to get that off with. piece of pipe over this. There we go. Break those loose. Comes. It's two really flat surfaces on top of one another. All right. That's been precision ground, and that's been precision ground. So again, according to my manuals, this top piece is just a cover that fits on here. There we go. And there's basically a drawbar that goes all the way down to this tapered piece in the bottom that this hull pulls in there, kind of like a milling machine shaft. So let me see if I can get something to pull that off with. I'm going to put some channel lock pliers on this. See if I can get it to break loose. Yeah, it's just not super tight. It was too tight for me to get off by hand. All right, that's just that drawbar. And I should be able to knock that out. There we go. Now, that should unscrew. Comes right out. And that's the arbor that was in there. And this is the arbor that I want to go in there. Make sure that taper is nice and clean. I will note that there is a little key on this, and there's a slot that it fits up into. Right there. We'll tighten that up on the top. I'm just going to do it by hand, and that should have the new arbor in there for the larger size cutters. And those cutters should just fit right up on there and tighten up into place. So looking at my little book here, it shows for the Type 7 gear shapers several different variations that they made. That's number 7, and number 71 and 72, 712, 75, 715, and 725. Now mine just says 7 type. It doesn't specify exactly which one this is, but based on the diagram, you know, you got your upper part where you just have a part, the shaper that moves up and down. Some of them have the tapers in them where you can change them out. Obviously mine has the tapers in them, so it's one of these 3. And then you got the bottom spindle down here. Some of them show a tapered work holding spindle, and some of them have a straight work holding spindle. It looks like what I've got is the number 712 cutter and work spindles. Now, the reason for the taper one is that it was designed to be able to change out that arbor like we showed, and that for gear cutting enabled you to be able to cut both internal and external spur gears, whereas this would only cut an external spur gear. So obviously they were using it with that internal shaft, but with a smaller cutter for external work, which works fine. They were just using it for the setup they needed, but this setup will do internal gears as well. As far as the taper, it looks like on the taper ones you would actually have a taper shank that kind of came up from the bottom, tightened up somehow, and there would be an arbor that you'd mount your gear on. This one is straight. I've got to figure out the work holding on all this stuff. Probably just going to have to make a custom work holding arbor. My guess is that it will just fit down into that slot there, and you'll bolt down the arbor to the outside, and then there will be a piece that comes up that the actual gear will fit down on to hold it while it's being turned. But the book honestly is a little bit lacking in the work holding part of all this, so I got to figure some of that out, but we'll get there. we'll get there. But I thought I'd show that little illustration there. I'll also show this chart, which shows some of the information in here on the machine and its capacity. Again, I think what I have is the number 712, which is this column right here. The maximum pitch diameter, so the diameter of the gear is going to be 7 inches, will be the maximum it'll do. The pitch diameter for an internal gear, the maximum is going to be 5.5 inches if we're doing an internal gear. And then the pitch, the spur pitch, is going to be a 6 pitch, will be the maximum. Of course, we can use a smaller pitch. 6 pitch is a pretty coarse gear though. And really a smaller pitch than that, like a 5 or a 4 or something like that, would be probably a bigger gear than this anyway. Maximum face width is saying 1 inch, but then there's a little asterisk out beside it. It's a 1 inch on internal gears and 1.5 inches on external gears. So that's the amount that it will actually, the width of the gear itself. So anyway, just some of the capacity of what this machine will do. Well guys, I think that's going to pretty much be as much as we can really do on this today. I've got some homework that I need to do. Running this machine, setting this machine up. I've got a little bit of documentation that came with it, some photocopies of some old manuals, and not a whole lot up on my website right now for this machine, at least in a manual standpoint. There's a little bit of stuff on parts and working on it, but not so much of running it. So I got some homework to do. Like I said, I need to figure out the work holding on this machine, the setup on this machine, etc., and get an actual gear cutter in where we can actually start playing around with this. I need to figure out, can you get new tooling for it? I imagine someone out there still making it. I don't think Fellows is still in business. They may be. I might have to go check it out. I just really don't know right now. But I know you can still find cutters like on eBay and places like that. And obviously I'm going to be on the lookout for some gear cutters that are the right size for this machine, which again, 1.25 inch diameter hole on the inside and roughly a 3-inch diameter on the gear, but they're going to vary a little bit depending on the number of teeth in that particular gear that you're using. That diameter is going to change just a little bit. But that's rough size of the cutter, so it's a pretty good size cutter, pretty much larger cutter than what we were showing before. I think the cutters we were showing before would be more for like doing internal gears, but again, they were using them for knurling instead of gear cutting. So anyway, anybody out there's got one of these machines and knows how to run it, let me know. I might pick your brain and try to learn a little bit more about it, because again, I've never used one, but really interested in playing around with it. So with that, that's going to be a wrap. As always, thanks for watching. Please subscribe if you haven't already. Thumbs up, comments, they really help out a lot. Big, huge thank you to those who support the site financially through Patreon, PayPal, etc. Really helps out a lot. Also now through YouTube memberships where you can join through YouTube. And with that, guys, we're going to get out of here. We'll catch you on the next video. Again, as always, thanks for watching.